Good morning to all of you. I am Akash Sharma, and on behalf of MIDAS, I welcome you all to this training session. So, in this training session, uh, today you will learn about three topics, which are as follows: slope stability using SRM method, like strength reduction method, the seepage slope stability coupled analysis method, and the tunnel wizard in GTS. So first of all, to start with, I will just give a brief introduction about slope stability using SRM method. SRM method is basically a numerical analysis which satisfies the force equilibrium, compatibility condition, constitutive equation, and boundary condition at each point of a slope. It simulates the actual slope behavior mechanism and determines both the minimum factor of safety and the failure behavior. So in addition, like in the previous methods, like in LEM, where we can have only the factor of safety, in this method we can have also like the stress strain condition in the embankment. So it reflects the real in situ condition better than most of the available methods. So what does the program does? Let us take an element, say element A, the initial stress condition defined by the condition as shown in the left of your screen. So what does the program does? Program goes on reducing the C and phi value till the failure condition is reached as per the Moore column criteria. And then the factor of safety is calculated as by FSS is equal to tau upon tau F, where tau is the shear strength of the slope material and tau F is the shear stress of the sliding surface. Today, in the demonstration part, first of all, I would be taking the model as you have shown with the following attributes. So to start with, this will be the model I would be generating. So I will start with a new model file. Let's first of all, you need to define the project setting. Like I'm going to develop a 3D model, and with you can also choose the unit system as per your requirement. So click OK. Then I will be defining the material attribute. Since I'm considering a 3D model, I would be using a solid attribute. Let the soil name be as soil itself. Adding the material property, I would be using ground. Let the name be soil. The material parameters which I'm going to use are as follows. I'd be using 1.05 E for the modulus of elasticity. MIDAS GTS provide with the following constitutive model like elastic, transverse, isotropic, Tresca, von Mises. For this particular model, I'm going to use Moore column method. So putting in the value for the gamma saturated, let the cohesion value be 20 and the phi value be 30. So click OK. Also in between, if you have any doubt, I would like you to request to just type it on the chat box or question box, as most of the people attending at a time, muting them all on is a bit voice problem because it's an online session. So having defined the property, we have just generated the. Now I will be showing you the modeling features. So first of all, and also I'd like to let you know that I am recording this session. And I will also be providing you the future YouTube link so that you can use it as a practice session also. So first of all, I would be starting with I will be generating a polyline. So I'd just be entering the coordinates directly. You can see the model being created on the screen. It would be of smaller of nature for now. So you can see that the polyline has been generated. Now to create the 3D model, I would just extrude it in the direction. So this is the selection filter. You can directly select the wireframe from here. The extrusion profile has been selected. Now I have to select the extrusion direction. Let it be the Z direction. A length of 25 meter for the embankment. You can just preview that what it look like. Yes, it's okay for me. So it goes like this. Now I have to move my work plane. So I will just move my work plane. I would be using a 3-point flotation for my work plane. These are the 3 points. Preview. So apply. So normal view. So now basically I want to create the wedge type, which I have already shown you in the presentation. So you can see like how easy it's to develop such a point. So I would just be putting the input coordinates. So you can see the polyline has been created for my model. Now I would be using a 3D model line for connecting the main parts. For this you should confirm that the vertex, the mid snap is checked on, so you can directly create the 3D model line. Now I need to create a solid. So that's the question, how to create that solid. We can directly use the extrude function. You can just once again check the selection filter to wire. So has been selected. Now while selecting the extrusion direction, there's a trick in here. So you just select the edge. So select the edge. Now I want the length of this edge to extrude the whole profile in that particular direction. So geometry, curves, uncheck both the polylines and select this one. And the GTS will automatically consider the length of this. You can just preview and click apply. So you can see the model which we wanted to create has already been created for you. So now we need to fuse both the solid into one. So this is your Boolean master solid. Let the other one be the tool solid. We want to delete the original one and we will merge the rest of the faces. Click apply. So it has been changed into one particular solid. Now I would be doing the mesh size control along the edge. Selecting the top view. Select the all of the edges for the wedge part. Let the number of division be 1.5. Preview. Let the interval length rather than, so it's better. Click apply. So I would also be controlling the edge size along these two edges. Let use linear grading. So SLEN is basically the starting length. So starting length, as you can see in the direction, is here. So here we need the mesh density as high. So we will use the value as 1.5, which was same as for that of edge, and ending length as 3.5. You can just preview. This is the preview button. So it's okay. Apply. Now we will go for the other two edges. As you can see, now the starting length, the density of mesh is not much required, but at the latter end we require high density, so it just becomes the inverse. It becomes 3.5 and 1.5. Click. We can just preview once, so it helps to remove the error, the preview. Okay, so the now we can, when we have already controlled the mesh size, we can directly mesh it using the auto mesh button. Select solid, You can give that as 5. You can select the attribute whichever you require. You can name this as slope. Preview. Okay, then click apply. So the mesh set has already been generated for you. So having defined the mesh set, now we will go to the next part, which is defining the boundary condition. So to make it easy, let's just uncheck the mesh set and just on the solid part. So for defining the boundary condition, go to model, boundary, and you can select supports, surface. This is the ground support for you. So you can just select the surface, let it be the two surfaces, and you can just click UX for it, apply. Select the other two surfaces, UX and UI, constraining UX and UI both, apply, and selecting the bottommost surface, click OK. So all the boundary condition has been generated. Now just for a simple analysis case, just give a load of self-weight rather than applying any kind of load. The load should be self-weight and let it be -1. Okay. So you can see easily we have completed the modeling part. Boundary conditions have been defined and the load condition has been assigned. So what we need to do is we need to define the analysis case. Click on add. So for 3D modeling we have SRM method. So strength reduction method. Let the name be SRM. Initial element, all the elements are required, so let it be all. Initial boundary, all the boundary, that is only the boundary condition, so let it be all. And for the load, just drag and drop the self-weight condition. Click OK. So here also I would like to show you the analysis control. Like if you want to define the water level, you can directly, if it's horizontal, you can directly input the value. Else you can, if it's a varying in nature, you can also directly put the X coordinates to show how the variation is going to take place. So you can directly do it from the analysis control. Click OK. So click OK. Then the analysis case for the slope stability has been generated for you. Now to save time, I have just used I will just be showing you the previously analyzed model. So let me open it for you. I'll just close it down because too many models. I'll just save it. Okay. So I'll be just showing you the analyzed model to show you that in addition to the factor of safety, the other conditions like the displacement, the stress strain condition at the time of failure is also provided by the strength reduction method, which is not provided by other methods like LEM, where you only have the factor of safety as the post-processing result. So you can see the factor of safety as calculated by the software for this method is 1.5875, which I already described how it's being calculated depending upon the shear stress criteria. And you can see that how the displacement is taking place. So this is the displacement, it's how in the dx direction, dy direction, and in addition to, like, you can have strengths, the 3D element stresses at various levels like the mean total. So this is how it looks like. So I would be showing the post-processing features much detail in the GTS in the tunnel wizard, while I will be describing about tunnel wizard post-processing features which can be implemented in any of the methods which I am describing today. So here I complete the first model on the simple analysis of slope stability. So moving on, the next method or the model which I'm going to take is the seepage slope coupled analysis. So what we be going to do in this method is that, first of all, a steady state seepage analysis will be performed on the dam. It's much similar to the one which you asked for earlier. So I have a few questions. I would just answer to them. There is a question like I want to ask that can we import any DXF or DWG files to software? Yes, MIDAS GTS supports DXF and DWG files, so you can import them. So this is a question from Mustafa sir. So this is the answer that yes, you can import the DXF or DWG file, but just to show the modeling features, I have not used them, but you can easily you can directly import it. We support even IGS, STEP and other standard format as well. So next, moving on to the second method. In this method, as the model sent by Mr. Mustafa sir was like for the seepage analysis, it takes into consideration also of that model. So depending upon the another question, so how long take the calculation of such a model? So the calculation time depends on the number of elements, but it's rather quick. Like for this model, it's something around 500 seconds. I have not checked it, but it's quick. Like and it also depends on the size of the model. If the modeling is too much big, then it will take much more time. And can we also import 3D solid AutoCAD models into GTS? So regarding this, I will check and I will let you know. I am not yet sure about it, so I will just note it down and I will get back to you regarding the 3D solid AutoCAD models. Okay, so I will get back to you via mail, sir, whether we can import the 3D solid AutoCAD models or not via email. I'll just check it and I will let you know. So I have replied to most of all of the questions. So yeah, it is possible. It is also possible to draw the structure by clicking without entering the coordinates, because I have just used the coordinates. I have just used the coordinates to simplify the process. So you can directly use the mouse cursor and directly click onto the button to draw the structure by just clicking without entering the coordinates. It is possible, sir. So if you have any more questions on the first model we have just ended, you can directly write it in the question box. I would be more than happy to reply. Okay, so I will proceed on to the next model. So in this model, what we will be doing is that we will be performing the steady state seepage analysis, and then we will be taking out the pore pressure results from the steady state seepage analysis, and in the same embankment we will be performing the slope stability analysis. So that is why it's called as seepage slope coupled analysis. So the material parameters which I have been using for this particular model, like I have core, filter and cell. For all of them I am using the more column method with the parameters as shown. Also to take into account the unsaturated condition of the soil, I have also taken into account the permeability function, in which the pore pressure varies with the K ratio. So these are the following for the core, filter and shell. And also I will be also be considering the variation of the pore pressure along with the volumetric water content for core, cell and filter, which I will be showing you in detail uh, in the coming slides. So first off, let's start with the modeling part. So this is the initial embankment for us. To start with, first of all, I have just imported the material property to save time. I will just show you model property material. You can see, okay. So you can see like the all the parameters has already been defined, and the unsaturated property which I was talking about is, we can also have a look at it. So you can see how with the K ratio, the pressure, you can manually input this permeability function data, or you can use the standard coefficient like Gardner, Frental or Van for the permeability, or same for the water content function data for like Von Guchen and user defined. So these are the available functions which are available with MIDAS GTS. So I have defined similarly for unsaturated property for core, filter and shell. So to start with, uh, first of all, we have just imported this model. Basically, I have considered the 2D modeling only for simplicity. So let's start with mesh size control. So first of all, I would control the mesh size. Just select the edges. Let the number of divisions for this part be 14. Let be 15. Apply. I will select the lowermost part. Let it be 14. Let for this part it be 1. Similarly, you can select the different edges where you want to control the mesh size. Let it be 5. Apply. And finally, for the edges, for let it be 3. So for this model, I will be using, as I have already shown you, the auto mesh feature in MIDAS GTS. For this, I would be using the map mesh, and especially for the K edge area. So you can select the particular edges for this particular, since you have already controlled it by controlling the size. So you can input the value as 1. The attribute, you can select any of the attributes, like for this cell. So in the advanced option, you can like generate mid-side nodes if required, and mid-side nodes are basically recommended for the SRM method. So since we are going to do SRM method, we would be generating mid-side nodes, and we can just preview and just apply. So you can see that a good quality map mesh set has been generated. So similarly, you have to generate it for all the other K-edged area. So to save time, I have already created another model uh, with uh, with already defined mesh set. So here it is for you. define mesh set. So in the mesh set, you can just see that 4 mesh set like shell, filter, and core. We have the 3 mesh set. The default mesh set is not of much concern. So we have the 3 mesh sets for defined for the particular model. Now to start with the seepage analysis, first of all, we will start with model. In the boundary condition, you can find the nodal head. So let us define it as flood water level. So type, let it be curves. So I'd be selecting all the curves. On the left hand side. So let the nodal head at the left hand side be 78 meter. You can also define a function as per your requirement, which you need to be defined as seepage boundary function. So for this particular model, I would be directly using a nodal head of 78 meter. You can preview whether it's defined, so you can see that it's been defined for your model. It's light in color. Let me zoom in so you can see that it's been defined. So you can click apply. So having defined the flood water level conditions, so let me define the drain boundary condition for the model. Drain boundary condition. So in the type of selection, you can select curve, surface, node, or free face node. Let us for selection, let it be the nodal selection. So let's zoom in the model in here. Select the nodes up to which you prefer the nodal boundary condition. So I have selected the particular 10 nodes and let the pressure head at this value be 0. So let's preview it. It's okay. Apply. So we have defined the nodal head boundary conditions. First the flood water level and then the drain boundary condition for the particular model. Now I would define model boundary. Then I will go to seepage phase. Let the name be seepage phase. So like the selection filter be curve, and let me select this curve on the downstream as the particular curve for the seepage phase, and let the total head value at this particular point be 47. Here's a question from Mr. Mustafa sir, that 78 meter is reservoir level or total constant time. Sir, it is the total nodal head above the particular slope. So it's the nodal head above each point. So we can say it's a reservoir condition. So for the ease, I have just taken as the nodal head to be constant throughout as 78 meter. So now defining the seepage phase, you can just preview. Let's apply. So we have defined, so just to summarize what we have done till now is that first of all we have defined the unsaturated material property, then we have gone for the map meshing considering the KH area, and then we have defined the boundary conditions for nodal head like flood water level, then the drain boundary condition, and finally the seepage phase boundary condition. Having defined this, now I would, since we have also to perform uh, the slope stability, we have to define the ground support condition also. So allow me to just define the support boundary conditions. So Let the name be ground support. So select the selection filter as curve. So you can just select the curves. So in total there are 8 curves, and you can just restrain the boundary condition as follows. So you can see that MIDAS GTS also provide you that the direct uh, application of fixed free pin no rotation condition, and also you can manually input as per your requirement. Just preview it. It's okay. Apply. So having defined the support conditions and the seepage condition, now we will consider the loading condition which we want to consider in this particular model. So first of all, allow me to define the load condition of self-weight. Please do consider that since it's a 2D model, so you need to consider the GCS direction. For the 2D model, in the GCS direction, the gravity direction we have selected as Y, so it should be along the Y direction. So let it be -1. Click OK. So the self-weight condition has been generated for the particular model. For this model, I am also going to consider a hydrostatic pressure load on the upstream of the dam. So we can consider like load, pressure load. Let the name as hydraulic pressure. So for this, I would be selecting the edge pressure because it's a 2D. For 3D, you can select the face pressure. So select the element edge, which are on the left hand side. You can select the curves for easy selection, or you can use the element edge condition. So the 4 curves have been selected. Now you can just define a uniform function for your pressure. You can select a uniform function, or you can define a base function as per the variation of your pressure load. For example, you can define like for in Y direction, let the name be value 3D, or sorry, value variation. And you can input the value as say 47, tab 80, 0. So you can see how I have selected the variation for the particular pressure. So click OK. So you can now select any of the base function which you have defined. Just you need to do input a pressure 1. You can preview the pressure, so you can see how the pressure is varying along the curve. So click OK. So the pressure load has been defined. So let's check how it's what we have done till now. So we have in the boundary condition, we have defined the flood water level, we have defined the drain boundary condition, and then we have defined the seepage boundary condition or the review boundary condition. Then in the loading part, we have generated the self-weight, and we have generated the hydrostatic pressure load. So having completed this part, now I will generate the analysis case for the steady state analysis. Just you can see steady state. For the steady state analysis, all the mesh sets are required, and the following boundary conditions like flood water level, seepage phase, and drain boundary conditions are not required. Ground support is basically defined for the slope stability condition, so I will be using it in the other part. So you can click OK. I'll just name this as analysis case 2. In the analysis control, you can control the convergence number of iterations and the tolerance value. So click OK. So the steady state 2 has been generated for you. Sir, about the seismic load, yes, we support seismic load. So you can also, like I will show you, model load, the response spectrum data and time history data analysis loads are all present. Like in the time history data, we have time history load set, time forcing function, ground acceleration, and we have also the response spectrum data analysis load set and function. So MIDAS GTS do support the seismic analysis too. So moving ahead, if you have any question, you can write me in the question box. The one who also don't have the microphone can directly write it in the question box, so I can see and I can reply to your queries. So let me solve this model for you. Analysis, solve. Okay. So it will not take much time. Therefore, I have just used this to better show the solving process, that MIDAS GTS is very quick in this respect too. So it has already been completed. The analysis has been completed. So in the post, you can see the results, especially the pore pressure head. So you can see the pore pressure head variation along the embankment, also the pore pressure, how the pore pressure is created. And also we have 2D element miscellaneous results like Vx center, Vy center, and else. So basically here I would like to focus on the pore pressure, because is it so we have another question: is it possible to apply more than one load on a boundary? So yes, it is possible, but it depends on the type of load you are considering. Like if I want to apply another pressure load on the same curve, I hope I'm getting you correct, then you can do it. It's possible. So if you have any other queries, please do write in the question box. So till then I will just continue. So you can see in the steady state analysis we have the different results. So for a geotechnical engineer, it's always necessary to understand how a particular embankment behave after the pore pressure condition. So MIDAS GTS provides you with a function of result from other case, where you can use the result from this seepage analysis directly into the slope stability analysis. So let me show you how it's done. So go to model load result from other case. You can select the analysis case and let the load set name be as pore pressure. And I want to just have the pore pressure data, and like steady state analysis and slope stability coupled analysis, we can import pore pressure. So you can import it, let it be okay. So you can see in analysis load, the pore pressure water condition has been imported as a load function. So now if you want to carry on with the slope stability on this particular embankment after doing steady state analysis, you can do the same. So just what the thing you need to do is, you do not need to create another model. You do not need to define all the conditions once again. You just now need is to define an analysis case. Let the name be SRM, because I'm going to use the SRM method for this particular SRM method. The initial element, all the elements are required. In the boundary condition, basically we only require the ground support condition, and in the load condition we require all the three. The hydraulic pressure, which I'm going to use, which I have already defined. The pore pressure is basically the one we have derived it from the seepage analysis, and the self-weight is the self-weight of the embankment. Click OK. So you can see the analysis case has been generated for you. So once again, to save time, I have already analyzed the same model to to show you the post-processing features. Once again, it doesn't take much time, but still in this training session I have to save some time, so I have not shown you the analysis time for this, as was your query, that how much time did it take to solve. So it was something around 500 seconds. So if you want, I will just send you the model and you can see that it's really quick in solving the SRM method also. So now you can see that for the same model on which you have done the steady seepage analysis. So this was your the pore pressure head variation and pore pressure variation. You have the slope stability results. So you can see how the displacement is taking place in the X direction, in the Y direction, and also you have the different stress strain condition uh, at uh, at the time of failure and at each point of the embankment. The factor of safety, as I already told you, how it's being calculated is 1.6625 for this particular model. And here I complete my second training model. So if you have any question, kindly write it on the question tab. I have a question. Is it possible to create a staged model? For example, analysis of embankment at different fill levels in model. Yes, sir. It's totally possible. You can do a construction stage analysis, and I will just show you the where you can go to model the construction stage. You can define the construction stage as per requirement, in which you need to activate and deactivate data as per your requirement, and you can just create your own staged model. So it is possible, and I will also be sending you a tutorial on construction stage just after this training session. So if anybody have any more queries on this particular uh, seepage slope coupled analysis, you can please write it on the question box. This type of coupled analysis, MIDAS GTS also support it with like consolidation stability. So I would also be helping with you the same, that you can see that what are the various coupled analysis which could be done in MIDAS GTS. So for now I have chosen seepage slope stability analysis as per the model you sent. So I think most of the projects which you do are basically focused on seepage and slope stability. So I have choose this particular model for your requirement. So in between, if you have any queries, please write it in the question box so I can answer it and I can proceed on the last model, and which is the tunnel wizard and MIDAS GTS. So I will proceed to the last model, and in between if you have any queries you can write. I would be more than happy to reply. So moving on, the last is the tunnel wizard in GTS. So I would be using the wizard which is incorporated in MIDAS GTS to build this particular model. As you can see, the model is like 122 meter high above the tunnel level, and in this there are three types of soil, the hard rock, soft rock, and soil. In between, I will just take a pause. There is a question. Can you calculate discharge on a specific plane in a seepage analysis? Yes, sir. I will just show you how it is done. Like if you want to know how the flow behavior is taking place, you can directly go to seepage result, and flow path and flow quantity. So from here you can like calculate. You can particularly, and if you want to calculate it in the particular nodes, you can directly use the input mode and you can use the calculate. So you can select any particular node and calculate, and the flow quantity will be given to you for that particular node. It is also true for particular curve also. So yes, you can calculate the discharge, and you can even see the flow lines, like how the flow is taking place in that particular model. So once again, to verify, I will just say go to result, and the result in the C page result, we have the flow quantity. So from here you can calculate the discharge on any specific plane for the C page analysis. So for the tunneling wizard, I had been using this particular model. Basically, here I would like to focus on the thing is that you notice that the tunnel is in the hard rock, and then we have the soft rock above it, and the final terrain is in the soil. Basically, I'm focusing on this point because since I'm using a wizard, I would be showing you that how easy it is with MIDAS GTS to build such a complex model within few minutes. So for the particular material models which we are using are like for hard rock, soft rock and soil, we are using the Moore column method with the given elastic modulus, Poisson ratio and the rest of the parameters. Similarly, for the rock, I have been using rock bolt and shotcrete for the tunnel with the following modulus of elasticity and Poisson ratio. And for the shotcrete, plate type of element is used, and for the rock bolt, the embedded truss is used for the modeling. So I will just close the previous models. So in MIDAS, you can also perform the tunnel intersection and complex tunnel geometry as well, but I am showing you the usage of the MIDAS GTS wizard, which is very useful and has been used extensively by our clients. So to show how it works, go to model, first of all create a new file, then you can select like it's a 3D geometry, so it's okay. Go to model, go to the tunnel modeling wizard. So in this whole wizard, like you can control your post-processing data, you can control your strata, you can define the material properties. You need not travel like for the various option, searching for the various option. In this single wizard, you can define, and like you can start from the material property, you can create your geometry, you can control your meshing size, and you can control your post-processing data. So this is how the MIDAS GTS makes it very easy with the usage of tunnel wizard. So to start with, first of all, we will start with the general features. Type is basically the type of tunnel which you want to create, like it's a full, or you want to create a half, or you want to consider a half tunnel. So for this training purpose, let it be full. The shape, what type of the shape you are going to consider for your particular project, like you want to have a full circle. So in the input guide, you can see the required parameters which you need to define, whether it's 3 center circle or whether it's 5 center circle. So accordingly, you need various definitions. So in the material part, it's here I want to focus on the focus of all of you. As I already told that the tunnel was in the hard rock. So this material is basically the material for the soil in which actually the um, tunnel is located. So this is basically, we need to define it as hard rock, the attributes of hard rock. So the model type for the tunneling purpose, we support elastic, more column, Hugh Brown, and Trucker pager. So more column. Let's define the elastic of modulus. So the parameters which I have is in ton meter square. So we need to change the unit system. So here we can also see that how easy is it to change the unit system. Directly you can click on the right and you can change in between the unit system. You do not do much trouble in changing the unit system too. So to start, let it be hard rock. Let the value for the modulus of elasticity be 6c plus 0.005. The Poisson ratio for the hard rock which I am taking is 0.2. The weight density being 2.6 and the saturated being 2.6, as I am not going to consider any water level in this particular model, so it remains the same and doesn't affect my calculation at any point. Let the cohesion value be 300 and the friction angle let it be 40 and the tensile strength let it be 40. So you have defined the material. So once again I would like to underline this fact that the first material property which you define in the general tab is basically for the soil mass in which the tunnel is present. So considering on the next fact, and there is a question from Mr. Mustafa sir, could we define concrete liner? Sir, I have, do you mean by concrete liner the rock bolt or shotcrete or the soft concrete? So we can consider the softcrete and the shotcrete, soft shotcrete and the rock bolt in directly in tunnel wizard, else it's possible, but in tunnel wizard we can consider only shotcrete and the rock bolts. This is particularly for the tunnel wizard. Yes, we can consider shotcrete and rock bolt only. So moving on, in the input guide, like now for the since we have considered the 3 center circle, we have to give the dimension of R1, R2, A1, A2, which could be known what are they by the input guide. We can also consider the include invert, like this type of tunnel and in the tunnel wizard, and we can also consider the asymmetric section, like where both the halves are not symmetric. We can also consider such type of section in MIDAS GTS. So for now we will consider a 3 center circle which is symmetric in nature and not inverted. So moving on, shotcrete and rock bolt. So here you can see comes the question to your answer, is that we can consider in tunnel wizard we can consider only shotcrete and rock bolts. So first of all we need to define the shotcrete property. So let the name be shotcrete. The elasticity modulus has been by default 1.5 E plus 0.006, which we have already been defined in our presentation. Let the other parameters be same, and for this we are not going to use the soft shotcrete, and let the plate thickness be 0.16 meter. Close. And similarly we need to define the rock bolts feature. Once again, these are the default values. You can see like the section we are choosing is circular. The element type is embedded truss. So you can also define it manually like by inputting the diameter and area, or you can use the database which is available for the particular rock bolt. So close. So having defined the shotcrete and the rock bolts, now I will consider the data of their arrangement. So numbers is basically the number of rock bolts which are you going to consider. Let the number be increased to 13. The length of the rock bolt, let it be 4 meter. Tangential pitch is basically, you can see that it's the tangential distance between the two rock bolts. let it be 1.5 meter. So the number of division, let it be 2. So starting with general, we have now defined the material properties for shotcrete and rock bolts and also defined their arrangement. We can also consider the staggered disposition of the rock bolts in tunnel wizard or MIDAS GTS. So moving on, next we come to the excavation part. So in the excavation type, you can consider the one direction or both direction excavation depending on your requirement. So for now, let it be one direction or unidirection. So advancing length, you can directly input like for the particular model is of 60 meter width. So 30 at the rate 2, and you can see it is automatically calculated by MIDAS GTS, and you can also see that how the excavation is going to take place. Here I would also like to focus on the point that rock bolt location is automatically calculated at the mid advanced level. Like you can see for each excavation, it is pre-assumed that the rock bolt will be inserted at the mid of the excavation. So if you want to change, you can change it at any particular level. You can change it as per your requirement by just switching on to user. Sorry. So you have just defined you have just simulated the excavation condition for the tunnel wizard. Once again, I would like to say that in between, if you have any queries, you can write so that you get a proper understanding out of the training. So moving to the next part, we go to mesh. So this is basically the general type of soil strata which is incorporated in MIDAS GTS, which is most commonly and satisfying most of the uses. So first of all, we need to define the tunnel location. So what is the depth? Depth below the bottommost of the strata. Let it be 60 meter. Sorry. Lower boundary is basically the lowermost portion. You can see in the figure, it's the basically the considerable depth below the bottommost part of the tunnel. Let it be 3 meter, and lateral boundary is 4 meter, which is basically considering the size of the model you want to consider for your project. Now we will come to the ground modeling. So in ground modeling, it depends. Like if you have only the rectangular portion, you don't want to consider the strata and terrain. You do not need to check the strata and terrain data. But if you want to have the actual simulation, you have to input like the data of the strata or terrain, or else you can just skip the part as per your project requirement. So for strata, so you can consider different strata in MIDAS GTS. So first of all, click new. So it doesn't mean that you can consider only one strata. You can consider 1, 2, 3 as per your requirement or as per your ground profile or soil profile. So for now, I will just having one strata. So I will delete the second strata. So first is the X variation, like how the strata is varying in the X direction. So for that, you need to input the value as per your soil testing. So I have already a value, so I would be using that for this particular model. Say 0 at 80 meters. So you can see like what my strata means in the figure. As I input the value, the line changes. In the 60 meter, what's the value? These are basically data from one of our clients and has been used in our tutorials as well. So you can see like how the profile of the strata, I will once again highlight on this point that this is for the strata. You can see just above the ground profile in which the tunnel is located, how my surface profile is varying is variation in only in the x direction. Now since we are considering a 3D model, we want to consider how it varies in the z direction. So we need to input the value for the same. So you can just use the input values in the z direction, and you can as well see it on the right of the screen that how my profile is varying. So you can see that how better you can simulate the actual ground condition in MIDAS GTS. Here I would also like to say about one of the features of MIDAS GTS, which is TGM, which I hope you have already heard, but it's like terrain geometry maker, in which you can directly import the DXF file from that DXF file of the ground condition and directly use it in your project. So here we have one of the question: if we use steel or beam for shoring of tunnel at specific intervals, who we can define it in the software? We can use steel arch beams for shoring of tunnel at specific location. Okay, so you can define it as a beam, and in the material property you can assign it the properties of steel. Like I will just be showing you, like since I have started the tunnel wizard model, just I complete, I will show you how to define the same. Like you will define the property attribute as beam, and in the while defining its material property, you can define it as steel, considering its E value, Poisson ratio, so you can define it as such. So having defined the strata, now the second thing, we have to define the material property for the strata. So let it be the soft rock, and the KOX value, let it be 0.7 in X as well as Y direction, and let the cohesion and friction angle be the same. Close. So you have defined the strata for the soft rock. Close. Now as I was saying that in this particular wizard you can control everything. So now we come to the meshing part. So you can consider the mesh part here itself, like how much the mesh height should be. Let it be 5 for the surface and 5 for the others. And for the tunnel, let the interval be of 2 meter. So we have once again I would like to summarize what we have done till now. We started with general, like starting with defining where the tunnel is, so defining the how your tunnel should be, whether it should be 3 center circle, 5 center circle, or 4 circle. And here I would also like to focus on one more point, which is the excavation method. For this method, like I was using full face cut, MIDAS GTS also provide with other excavation method, which you can see on your screen. Like we have the bench cut 2 method, bench cut 1 method, ring cut 1, ring cut 2, and as well as the CD cut method. So MIDAS GTS provide with most of the common and in practice excavation methods, which some of them are incorporated recently as per our client requirement, and some of the traditional or the conventional excavation method are always present in MIDAS GTS software. So for this we have been using the full face cut method. Now having defined the general parameters, then we moved on to the shotcrete and the rock bolts. Basically we have defined their material properties, and we have defined their arrangement which we require. Then come the excavation part. Like we have considered only one direction excavation in this particular model. We could have considered both also, and we have like defined the advancing length in which we want to consider our excavation. We have decided like we will excavate 2 meter at a time, and we would be considering the rock bolt and shotcrete at each 1 meter interval. So it's been auto calculated and very easy to determine. And also if you want to consider the different load factors after particular construction stage, or you can consider that too. Then finally we moved on to the mesh part, in which we have done the ground modeling part, defining the strata, and we have defined the strata. Now I would like to define the terrain. Terrain is the topmost part of the tunnel. So just click on terrain. So the data which is available with me is of 11 by 11. So we can update the size. So you can input the data directly. Like this is, I have an elevation.dat format. So open. So the data has already uh, been filled in the format. And now we have to define the terrain. For terrain or the topmost soil, we can name it the top soil, and we can input the various parameters for the top soil, like let the Poisson ratio be 0.3 and the coefficient for lateral pressure be 0.5 and 0.5. Close. So we have defined all the parameters, and we have then controlled the meshing size which we required for our particular model. Now moving on to the last part, which is the post data. Especially these are the main points which a geotechnical engineer want from his project, especially not uh, in a 3D format, or basically in Excel format, where he can file his report and show it to his boss. So these are like the vertical displacement of the crown, the side wall displacement, the vertical displacement of the bottom point, the maximum compressive stress, how the shear stress is varying, and how the axial force is varying. So with the tunnel wizard, MIDAS GTS provides you the direct facility of calculation of this in Excel format along with the graphs, which I will be showing. So you can like consider the different stage selection as per your interval requirement, like how much interval you require. Like let's say for vertical displacement of crown it be 5, okay, then the side displacement it be 5. It is basically the interval after which you want to see the calculation. So the smaller the interval, the larger will be the size of actual sheet. So just to show you, I am reducing the interval size to 5. So we have inputted all the parameters, right, starting from general to post data, and now you can click OK. And within few seconds, the whole of the model will be generated for you. So you can see the whole model is being generated for you. Let me just hide the boundary condition. So you can see the whole model, which otherwise would have been very difficult. And since it's a common type of soil profile which is found, like you can alter the soil state of a 1, 2, 3, 4 as per your soil profile variation, and you can just input the terrain as per the geotechnical investigation data. So not only this, the construction stage has already been defined for you, so you need not worry about the different construction stage. Also, if you want to consider the different water level, you can input the value here. So you can see that with Tunnel Wizard, within a few steps, a complex 3D geometry modeling has been done within a few minutes. Now we'll go to the analysis case, and even the analysis case for the construction type has been generated. So if you want to do any modification on your own, you can consider it in here. So like since we are inputting cannot condition, uh, calculated cannot condition, we would not consider it for the initial stage stress analysis. So you can uncheck it in here. And if you want to like change any of the scheme, iteration scheme, you can check in it from here, your convergence criteria and all, and even the number of iteration and the tolerance value. Okay. So here I have completed the analysis case. So before I move on to the post-processing part of the same, showing the various techniques of seeing the result, if you have any query in between, please do write me in the question box. So for now, I will show you the fully analyzed data. So please feel free to ask any question so that the training program which is scheduled for you uh, brings some good aspects for you about MIDAS GTS. Okay, so now I will be showing you the post-processing features which we got after the analysis. So I will just uncheck the support condition. So in the post-processing features, in the initial step, we have defined 12 construction stage for this particular model, and for each step we get the reaction, displacement, strain, stress, and 3D element status for each stage. Like in 3D element strains, you have different values as calculation, and even you can consider the 3D element stresses like the von Mises center, the Tresca center, the mean total center, and all the basic and advanced requirement which geotechnical engineer look for are available with MIDAS GTS. So basically now I will be showing you the different uh, how to unveil the various post-processing features. The same goes true with my previous two models. You could have used it in other two, except the second one, which was 2D in nature. So the features which I'm going to show can be used in any of the 3D modeling 3D model which you create in MIDAS GTS. So first of all, I would be showing you. You can go to the post command data. Is the ISO surface. So any particular value if you want to consider, you can use the ISO surface condition, which many times is helpful in complex 3D projects like tunneling. So you can control the property values, like this one is for the particular value of -1 plus 002, and similarly you can add your own type and you can consider the ISO surface. The next is the clipping plane. First of all, let me do it as original, and now I will show you clipping plane define. So you can see the different stress or displacement contours as per your requirement. You can just rotate the clipping plane, or you can move even forward or backward to consider at a different point. So with the clipping plane, especially it's help like to study the variation at the center of excavation. So you can consider always the clipping plane. Similar to clipping plane, we have another surface called the slice plane. In the slice plane also, basically it's similar to the clipping plane, but in this a particular slice is studied, and you can obtain the various results for the same. Like I am showing you for the soil mean total center, and you can consider it for a particular plane, that how the variation takes place on a particular slice plane. So let me do it original. Let's go to the front view. Okay. So now if you want to see like how with the construction stage the variation is taking place, so you can also consider directly it in from here. You just need to click, and with the stages it will show. You can see how the variation is taking place with each construction stage. So you can see like how the variation takes place in a particular direction with each construction stage for each parameters. Okay, now one thing which we did was we exported some of our important post-processing features into Excel format. These are the generated Excel sheets which I would like to share with you. First of all, the axial forces in the rock bolt. So you can see that with how the axial force in ton, which is the unit, how it's varying with each construction stage. Not only the values, but also a graph, which is very important for making like your report, which you present, is generated automatically by MIDAS GTS. So this is true for axial force. Similarly, I would like to show the other Excel file sheet as well. So the next is the stress condition. So you can see like how the stress is variation. So not only the values but also the variation of the stress in particular direction can be seen. Here is a question from Mr. Mustafa sir, that could we model vertical shaft with tunnel excavation? Sir, vertical shaft, I think you are trying to ask me about the other tunnel connections or the particular thing. So we do consider different tunnel connection, uh, different tunnel connection as well as intersection in MIDAS GTS. But sir, I would like to focus on the point that with um, tunnel wizard, it's only possible to make that particular standard type of model. But like when we do normal modeling and stuff, we can always consider such type of intersections. Like we can consider tunnel intersection, and so with vertical shaft, yes, we can model, we can do that. So similarly, we can have the important parameters like bottom displacement, wall displacement, and crown displacement of the particular node, which are always a prime source of requirement for any geotechnical engineer considering the tunnel excavation uh, for their modeling. So now I'll just show you some of the other features like how to control display and stuff in tunnel wizard. So in the results, you can always extract the result, like whatever you result other than this, because in the tunnel wizard we have standard format for the 5 parameters which you have seen, like we have directly extracted it in the Excel format. But if you want to extract any other result other than that, you can always consider the same by using the extract result. This also goes true with any of our 3D modeling features, which was also true for the SRM method, which we started with the first training topic. On curve diagram, like if you want to see the variation of like any particular parameter like displacement on between 2 points, you can always consider that using the 2-point diagram. So you can see that how the variation will take place. And this is a 2D, it's difficult to see, but in 3D modeling it will be more clear when you consider any particular 2 point of interest. So it would be, you can see that how the variation takes place between the 2 points. Similarly, we have different, you can always save the result image file and you can consider it while you are considering your report. So I have completed with basically all of the 3 topics, and if you have any queries on the 3 topics, please do write me on the question box. And before ending the training session, I would just go through a brief presentation on GTS NX, which is our next release, and I would like highlight some of the important features of GTS NX to you. So if you have any question, please do write me on the question tab. I have a question, like is it possible to modify the tunnel section according to results quickly? Sir, quickly means you need to, like it's a trial and error method. No, you cannot do directly. Like you have to change the size of your tunnel and then you can once again check the results, and you can like let the results be in accordance to your requirement. So quickly, like if you want to directly after the post-processing features, you directly want to change with tunnel wizard, yes, you can like directly go and create a new model, but for the rest you need to do the modeling once again. But that's the importance of tunnel wizard. Like you can just check your model, you can go back, you can, because it doesn't take it hardly takes any time, so you can quickly switch once again. You check your result, no, it's not safe, I want to go with a different type of excavation, I want to go with a different type of tunnel section, yes, you can do with that. So here the tunnel wizard plays a very important part. So regarding the shortcrete and the rock joint, we have a model, but I have to check whether it's possible in tunnel wizard or not, but we have a model for considering the rock joint. I will just check it and I will confirm it to you via email. I have noted the question of yours, and I will give you a I will just check up with my senior and I will let you know about this. So if you have any other question, you can directly write to me on the question box. Okay, in between if you have any question you can ask me, and for now I will just give you a brief introduction about the GTS NX features. So to start with, in GTS NX it will be a new generation platform. It will be a completely supportive system for a 64-bit software, and it can support a very large scale models, which I will be showing you in the upcoming coming slides. With the autonomized modeling, it has the stabilized geometric calculation and diverse automatic tools, and it has a universal solver. As you all know, till now MIDAS GTS was in collaboration with TNO for its solver. The post and processor were with MIDAS and the solver was with TNO, but now with MIDAS GTS NX will be going to have our own solver. So with GTS NX, we have a better mesh quality because with hybrid mesh, the addition of high quality hybrid mesh capability, which is applicable to all the analysis function in order to extract the most results. So it will be incorporated in GTS NX, and we would have the hybrid mesh too. Manageability and support for large scale models. You can see very large scale models like you can see on the screen, like solid, the number of solid being 3250, the number of element side being 394,100, which is very huge in nature, can be managed and supported by MIDAS GTS NX. Additional of the automobile modeling function, you can see in the video that the contact features, whenever we have different types of mesh set, there was always a confusion between in our clients that how does it behave. So with the addition of automized modeling function, you can save your time and avoid errors for the 3D solid shared surface and imprints. Generation of topography layers in 3D based on actual fieldwork, you can directly import. This is what I was talking in. This is basically the TGM, the terrain generator maker, in which you can directly import the DXF file in AutoCAD and directly import it in your GTS NX to directly have an actual ground profile for your model. So it would help in better simulation of the actual ground condition. Extension of the function of analysis summaries. So with MIDAS GTS NX, the report function will be on PDF nature, and where you can rotate the 3D modeling, the whole 3D model itself in the PDF, and you can adjust or take the the actual view which we required for that particular feature. Like you can rotate the same thing, just like you rotate it in the software, you can rotate it in the report, and uh, you can take the snap at the particular point. So a very printable PDF file which includes an adjustable 3D view and decibel unit transformation features will be incorporated in GTS NX. We have new high-end solvers, like you can see with the GTS which required like a time of 29 minutes. GTS NX will improve the analysis time to 6 to 12 times and would be able to complete it in, say, around 2 minutes 30 seconds. So that's why very large models could be managed and solved by GTS NX. So rigid and fixed contact, like wherever the different mesh sets are there, you can always be, there was always a confusion that how the contact could be defined. So with rigid or fixed contact, it guarantees the continuity of the analysis result. GTS NX also provide with the advanced nonlinear dynamic analysis. So the geotechnical and earthquake engineers, which basically both want to simulate the actual ground condition considering the nonlinear dynamic analysis. So GTS NX will also provide them with such kind of seismic analysis. So it's a very advanced features which is not found in many of our competitive softwares, will be incorporated in GTS NX. So in the GTS NX 2014 R1, that is the 2014 release, we will also incorporate some of the features like the soft soil creep model, the hardening model, which is basically the modified Moore column method, considering also the concrete creep, like the creep shrinkage for like different geotechnical parameters, like for rock bolt and stuff. Where concrete is used, we will also be able to consider the creep effect on the concrete at that particular point. We also could consider the geometric deformation analysis, would have the embedded 3D beam element, as you can see in the figure, and we have 3D to 2D, the automotive save of the singular surface. So more thing which will be added will be the model for liquefaction material, the viscoelastic material models considering soft rock creep, and it will be also linked with the SoilWorks data, so you can directly drag and drop the single surface information tabs. Here I would also like to highlight the point that GTS NX price is expensive than the old GTS, and if you like want to consider the same, you can contact Mr. Adrian or our technical or our partner from Turkey regarding the same. So if you have any query, you can write to me on the question tab, or you can better email it in esupport@midasit.com. First of all, I would reply to the question from Mr. Mustafa sir. It's regarding about the method instability. Instead of strength method, could we use other limit equilibrium methods like bespoke, Janbu, ordinary, Spencer? Okay, sir. So the thing is that MIDAS GTS does not support limit equilibrium method. So in SoilWorks, we have the limit equilibrium method where you can consider all of these parameters. What MIDAS GTS support is SRM method, that is the strength reduction method, and SAM method, which is the strength analysis method. I would like to just focus on a bit about SAM method. Sir, SAM method is basically a combination of SRM method and LEM method. So what the program does is that, like suppose it is like both the combination of both. LEM method, from LEM method we have the failure surfaces, like it will define the arc failure surface, like where you expect the failure surface, because as you have already seen in SRM method we do not have well defined failure surfaces. So in SAM method we define the failure surfaces like just as we define in the LEM method, but a stress analysis is simultaneously done same as in SRM method. So the advantage comes that we have well-defined failure surfaces, and as well as we have the stress condition in the soil for that particular model. So it's a combination of both, and it's very effective. I would be sending you SAM method, analysis manual of SAM method, so you can find it very useful. And yes, the reply to your question is that, sir, in GTS limit equilibrium method is not supported, but in SoilWorks it's supported, and it support all the methods which you asked, like um, Bishop, Janvu, and all other advanced method also. So that's the reply, sir. In GTS, no. SoilWorks, yes, but GTS provides you with SCM method, which is basically combination of SRM as well as LEM method. And for SoilWorks, sir, it is basically a 2D software. So that's why, and as you know well, that LEM method is better simulated for the 2D, and for 3D it becomes a bit complex. So that's why SRM method is basically used for 3D modeling. And we have kept it the LEM method, and all the methods you talk like Bishop, Janvu, etc. are all there in the SoilWorks. So this is the reply to your question. So if you have any other question, so you can write to me now, or otherwise I will give you an email ID and where you can just reply to me. It's on your this is on your screen. You can directly write to me on esupport@midasit.com. And regarding two of your questions, first one was regarding the joint in rocks, and the second one is whether we could import 3D solid AutoCAD models or not. I will get back to you very soon via email. I will directly reply to the question, and I would also sending you a tutorial on construction stage analysis as well as the analysis manual for LEM, SRM, and SCM method. So you could better look at the three methods and the different aspects, how it considers the factor of safety and all. So if you have any other questions, you can ask me. I'm waiting for your questions. Okay, so I would just like to stop since you don't have any question. So in between, if you have any other question regarding the other modules like consolidation or other, you want to know about the various aspect, whether it's supported in MIDAS GTS or not, you can directly write to me at esupport@midasit.com, and I will get back to you. And you can also for sales and other perspective, you can contact our international team manager, Mr. Adrian sir, or our technical partner from Turkey, Ms. Harika or Burak. So you can contact any of them regarding the sales. And if you have any, if you want to know about any technical features, you can kindly write it to me. So thanks a lot for joining uh, the webinar. I, Akash Sharma, on behalf of MIDAS South Korea, thank you all for attending this training and training session. And okay, yes sir, I will email. It will not be possible to email you the recorded session, but I will just send you the YouTube link. Okay, once again I would like to thanks you all on behalf of MIDAS, and hope MIDAS come up with a better solution for your projects. Thank you very much.